In this module, we're going to discuss naming and why it matters. So what's in a name? Well, we're about to find out. Here's our plan. We're going to discuss why naming is so critical and learn some principles for selecting good class names and some names to avoid. We'll learn how to avoid surprising people with nasty function side effects, and we'll wrap up with some principles for selecting good variable names. So let's get started. Variable name selection has a huge impact on the readability of our code. This code snippet is simplistic enough that you can likely determine what it does, but without well-chosen variable names, it's completely unclear if the code does what the author intended. Remember, understanding the programmer's intent is the biggest problem, so we must strive to be crystal clear about what we meant to do. Imagine reading a book with random one-letter abbreviations throughout. P was very angry with G for insulting her M. G kicked P in the A. He slept on the C. It reads a bit like a bad game of Mad Libs. Now, can you sort out the gist of the story by using the context around poorly chosen names? Sure, but it's taxing and it adds unnecessary confusion. The situation is even worse when programmers use misleading names that actively mask intent. Note how much easier it is to read this clean version. The only change that's been made is better variable names. Let's compare reading them like a sentence in a book. Define list of P as decimal. Define T as decimal. For each I in list of P, add I to T. Return T. This is a simple problem, but it sure sounds cryptic. Compare that to define list of prices as decimal. Define total as decimal. For each price in list of prices, add price to total. Return total. That's what's going on at the bottom. I'm just reading off using the variable names that have been provided. Now note, as we'll discuss in a later module, there's a clear opportunity to further simplify this clean example using the sum extension method in C#. But this example clearly displays an improvement by simply selecting more descriptive names. Alright, pay attention because this is key. Well-named classes are critical for assuring that your application remains maintainable over time. Why? Well, I've seen plenty of times that poor named classes become a clear magnet for the lazy. How often do you come in on a Monday in a lousy mood, not really feeling like doing your job, and you need to add this new feature, but you don't really want to think about where it goes and whether it warrants creating a new class or being composed within an existing class? Well, when your project has poorly named classes like these examples, they are a magnet for lazy developers. It's easier to just throw your code in one of these spots than it is to think about where it belongs. These magnet classes quickly grow to thousands of lines of code and become very difficult to understand and maintain. Nobody really understands what their purpose is and what the consequences are when you instantiate one of these massive classes. So, in contrast, let's look at some cleaner examples. But note that depending on your project, these examples may still be too general or high level. A well-designed class should have a single responsibility, and its name should help reflect that. Given single responsibility is a tricky judgment call, but it's certainly helpful to regularly ask yourself if the class is doing too much. Here's a few guidelines for naming classes well. First, good class names are nouns, not verbs. When you instantiate a class, you're creating a thing. You should be able to reason about creating an instance of that thing. The name should be as specific as possible. Keep in mind that specific names lead to smaller and more cohesive classes. What's a cohesive class? Well, a cohesive class has methods that regularly interact with one another. So a class with low cohesion would have many methods that do totally unrelated functions and rarely interact. Naming is especially important with classes because a class name forms the foundation of the design and thus indicates when the design is headed in the wrong direction. The name should help lead the design in the direction of a single responsibility. You can imagine that the product repository class should know how to query the database to get products, but it shouldn't know how to send product emails. The name alone is specific enough that it's unlikely anyone would be tempted to put such unrelated logic there. Finally, avoid lame generic suffixes that add no value. A class storing business logic about products should likely be called product, not product manager or product info. If you're wondering about the quality of the name you've selected, ask yourself, is an instance of this logical? An instance of a product is quite logical. An instance of a product manager or a product info? That's confusing. Remember in school when you'd get assigned long chapters of boring reading? Well, lousy method names put a very similar burden on your fellow programmers. Now that may sound a bit odd, but here's why. Poor method names require the reader to read the whole class before understanding what it does. Look at these examples of poor method names. Without reading the code, you literally have zero idea what logic is inside. None. You know nothing about the class if these are the method names. Now, you'll also notice that the .NET Web Form page lifecycle methods are listed under dirty as well. Many frameworks offer pre-named magical methods like this that get called automatically by convention. But always keep in mind that these methods are by definition poorly named methods because all they do is tell you when they are called, not what sits inside. By reading the names on these methods, you know nothing about what's going on. Now you obviously can't go renaming them because that's baked into the framework, but what you can do is only place method calls inside. This gives the reader a quick high-level view of what you're trying to accomplish at that point. Now remember, the bottom line when naming methods is to select a name so descriptive that the reader doesn't have to read the method to know what it does. The good examples on the right fit this description. There's no need to read the body of these methods if the description doesn't sound like what you're looking for. We'll talk more about the implications in the functions module, but it's very clear as you look at these, you really don't have to branch them out. Get registered users. You can pretty well assume what's inside. Is valid submission, import document. These are self-explanatory names. Now, we will also talk about some risks that can go on if people don't honor these names, but assuming that the programmers chose a name that was descriptive of the logic, you can save yourself a lot of reading when you're hunting down a specific bug. Now, naming should be easy when you honor the single responsibility principle. If your class or method are doing one thing, it should be easy to describe what the code is doing. But if you've been coding for a while, I'm sure you've had the experience where you've been stumped and had to ask a coworker for help, and then halfway through your explanation, the solution just strikes you. By verbalizing, you exercised a different part of your brain. That's how you figured it out. So in the same way, if you're having a hard time naming a method or a class, it often helps to verbalize. Explain what the class does out loud. And if you don't have a coworker that wants to listen, just keep a rubber duck on your desk. If there's no one around who cares to listen, explain it to the rubber duck. This sounds silly, but it really does help. Also, pay attention to how broad your description is, particularly when struggling to name a method. Ask yourself, am I describing one thing or a set of separate concerns that should potentially reside in separate classes or separate methods? A well-structured and named method shouldn't surprise consumers with unexpected side effects. For example, a method called checkPassword shouldn't log the user out, and validate submission shouldn't save. When I ask for getting a user, I'm not going to expect that to create their session, and charging a credit card most certainly should not send emails. Those are separate concerns, and when I call that one method based on its name, I'm not going to expect those items on the right to happen. So make sure that your methods don't lie to your readers. Otherwise, people have to read through every line and make sure that it does exactly what it says it does. We want to be able to trust the contract that you are exposing through the method names that you select. When naming methods, keep an eye out for warning signs. If you find yourself using the words and, or, if within your method name, it's a sure sign you're trying to do more than one thing. Common examples include save and email, load and copy, calculate and display, process or deny. If you name the method to describe everything inside and need to use these words, it's a sign you need to create two methods, not one. Hey, remember the 80s? Well, it's not the 80s anymore. So abbreviations within your code just don't make a lot of sense. Back in the 80s, storage was quite limited and expensive. These days, storage is cheap and IDEs are robust. We can select long descriptive names and IntelliSense saves us the time required to retype them. We just strike tab and magic happens and the rest of the text appears. See, the problem with abbreviations is few words have a consistent and unambiguous abbreviation in the first place. Imagine reading a book or article filled with cryptic abbreviations. If the author never expounded on these short terms, it would make for a seriously frustrating read. Since there's no standard, abbreviations are just to be avoided. Also, keep in mind that we talk about our code, and often we read it silently in our heads. Awkwardly abbreviated names hinder discussing the code. Imagine that we have a class called register user. Well, if instead we call it reg user or regist user or regis user or register user, none of these flow off the tongue. It makes it more difficult for us to read the code and more difficult for us to have a conversation with our colleagues when issues arise. Go ahead and put in the full name and let your IDE make it easy on you. We don't have to type out all these characters anymore, and a little bit of extra storage won't hurt anything. Naming Booleans well seems to trip up many developers. The key rule is well-named Booleans should sound like they're asking a true-false question. Naming a Boolean well helps your code read like spoken word. Let's look at some dirty examples first to show what I mean. Open sounds like a command, not a question. Same story with start. Status is ambiguous and awkward since a status of true or false makes little sense. Instead, let's look at some clean examples that are clearly storing the answer to a true or false question. Is it open? Is it done? Is it active? Conditionals that use clean Boolean names read very naturally. Let's look at how awkward it is to read the conditional with a poorly chosen Boolean variable name. If login versus if logged in. What does a true login mean? If logged in is true has a clear meaning, and that's the key. It should be asking a true-false question. Sometimes we deal with opposites in our code, and when we do, it's important that we select variable names that have symmetry. They should be clearly opposites. Here's some examples of poorly chosen pairs: on, disabled, quick, slow, locked, open, slow, and max. Now, these are all generally related, but they're not clear opposites, which makes them confusing to work with together. So let's look at how we can make these clean. On works with off, fast and slow, lock and unlock, min and max. It's even easier for me to read quickly to you on the slide. When you have these opposites to work with in your code, make sure that they are clearly opposites. A lot of words have obvious choices on the other side, and it will make it easier for people to read and reason about your code. In this module, we explored key naming principles. Ideally, the name should say it all. It should clearly convey what is being stored and what lies inside. We should be specific about class names to help avoid creating magnet classes. Magnet classes have unspecific names. Such names tend to attract unrelated logic. When naming functions, watch for function side effects. The function's name should accurately and comprehensively describe its behavior. Descriptive function names avoid surprising fellow developers and also help encourage reuse. Avoid non-standard abbreviations since they hinder reading and comprehension. So if there's not a common standard for the abbreviation, avoid it. Booleans should sound like true-false statements. It should be self-evident from the name alone that the variable stores a Boolean or that the function returns a Boolean. Strive for symmetry in related values. When you're dealing with opposite states, try to pick the logical opposite. For instance, prefer on-off over on-disable. Finally, if you're struggling to choose a good name, consider verbalizing your problem with someone else, or even just talk to yourself. In the next module, let's explore clean coding principles for writing conditionals in C#.